Are you guys able to see my screen? Good. Um, so as I was saying that exploratory data analysis, or what we call the EDA, is a crucial step in any analysis task. It involves examining and visualization. I mean, examining and visualizing data to understand its key characteristics, um, uncover patterns, detect anomalies, and even formulate hypotheses. And in this case, I just have an example. I have an example whereby we are going to be dealing with insurance data. I think I shared the data in the group. So I think you can just download and then you upload it in your collab or whatever ID you're using. So that we are able to move together. And today I just want us to cover the ADA process, just that, so that now tomorrow we are going to start uh, something new because I want us to start learning machine learning. So you're going to have like 5 days for learning machine learning, checking the models and stuff. But as for today, I just want us to check the ADA process. So that is it. I'm waiting for you guys to upload the data. I think I should be as well uploading my data. Should be somewhere. So I'm assuming that you guys have been able to upload your data, so that we can start the process. So we always start the process by importing the libraries. And the libraries that we are going to use here, they are just three of them. That is pandas, uh, matplotlib, and also you're going to see use the seaborn. And I think you can just do that. You can just open a new cell that is in your collab. And for those of you guys who are using the other IDEs, you can as well as create a new file and call it EDA process, so that we can at least move together. So in my case, I've already done the import. So you just import pandas as PD, you import matplotlib.pyplot as PLT, and then you import the seaborn as an S. After that, the next step is to load your data set. And in this case, I think I can just copy the path Just replace these. And uh, the first thing after you upload your data, I think you can just let us just understand the structure of this data set by displaying the first five rows of our data. So you can just run through these. Yeah, and you notice that my data has how many columns? Let's check. We have the company, we have the town, the number of policies that the company has, the assured amount, and we have type of policy, and also the customer rating for each policy. So this is I think by now, I think now we by now we have understood the structure of this data, because now at least we know we have about that is 1, 2, 3, 4, 5, 6. We have like six columns of data, and also we know that our data is it's kind of dealing with insurance in different towns, and also it's insurance for different companies. You know, like you are trying to understand these data sets. The second thing after understanding the structure of your data set, I think you can just move on and check the dimension of the data set, so that you can at least know how many number of columns do you have. I mean, you already know the number of columns that we have now. What is remaining is to know the number of rows we have, or the number of uh, yeah, rows that we have, and we do that by I don't know if I introduce these the shape the shape the shape functionality. This one helps us to check the dimension of your data set, and in this case we have 1 or 2 rows and six columns. I think you have already counted the number of columns that we have. But if you have so many columns, you can just use this df.shape, so that you can at least know the dimensions of your data set. So in this case, the output here, we are told that the shape of the data set is 102. We always start with rows and then the column. So if we were to rerun these, I'll just get, oops, 103. Did I add a column maybe, a row maybe, I don't know. But now we have 103. I think I added some data. Uh, so yeah, I think now we are getting to understand this data set. If, even before we think of doing an analysis, that is the purpose of this EDA process, like familiarizing with your data set. Because at some point you will get a large data set, maybe 5,000 rows of data, and even maybe data having maybe more than 20 columns. So it's always good practice, and this process, EDA process, will always help you to familiarize with your data set before even you think of doing any analysis. And that is what we are doing right now, understanding this data. So after uh, the dimensions that you have in your data set, we can move forward to check at least you know some we get some information from this data. And I think we already used the info method. Again, this one will help us to know the number of columns, the names of the columns, uh, the number of rows we have in each column, or what you call entries. So in this case, we just have to run this df.info method. Then you just get to know that. I'm assuming I'm not too fast because I'm assuming that you guys you are writing code on your end. Are we together up to that point, or I'm too fast? Someone can just confirm that you are up to that point. You are together. Good. So checking the info. A question, Mario. What is it? Okay, I think you can just move forward. So, and I showed you how to read this information.
Sir, we mean we are not together when Mario says no, James.
Sorry?
It means that you're moving so fast.
But you guys are not saying, because I asked and I can see some thumbs up that we are moving together. Am I too fast?
No, you are too fast, James.
Why did I lost you, Mario?
I've not even uploaded my file.
Oops. I think you joined late.
No, I was on time.
Okay. So can you start by uploading the data?
The reinsurance data.
Yes, the one I shared on the group.
Okay.
Yes, I think you can upload that very fast. Any other person who had been left behind? Amos, are we together?
No, even for me, I was just left behind. So
Just we start by uploading the data. I think I can give you 2 minutes for doing that. It's quite simple to upload data. And even you can go ahead and import the libraries that I have already imported in this file.
Now,
Yes.
my data is just uploading na inasimama tu hapo. It's not uploading. I don't know.
How did you upload it? Can you see what you
I
have?
clicked on the file. You see that upload session to storage.
Yes.
That's where I clicked. Then ikanipeleka kwa downloads. Then I got the data.
Yeah.
So after I clicked, it's just running on the disk. Alafu ina disappear.
Then you can it means that it has already uploaded. Where you are uploading it to, which folder? The sample data.
Yes, the sample data.
Can you check if you already have it?
Now it has uploaded. Sorry.
Yeah, you should have it. Any other person who is left behind on uploading the data? Okay, have we all uploaded the data?
Yes, I've managed.
Let's check Solomon. Solomon, were you able to upload the data? You can just confirm. Lewis, Lewis is okay. So, Solomon, Valentine, Emily. Solomon is okay as well. Emily, Derek, Derek, Amos. I think also Amos. Good. I think now we are together. So after uploading the data, I was saying that we are going to use three libraries in this case. That is pandas, matplotlib, and seaborn. So I think you guys know how to do this, to import these very fast. So I think you can just import those three libraries very fast. That is always the first step, by the way, in the EDA. Mariwa, have you managed to import the libraries?
Yeah, I'm in that process.
Okay, I'm giving you 2 minutes to finish up.
Okay.
Yeah, so that we can move forward.
Excuse, that library is importers.
Which one?
Import seaborn.
Yeah, it's
Marine.
called Seaborn.
S
Seaborn.
S
S and S. I think I talked of it yesterday. Let me just try to zoom out this. I think it's now visible, right?
Yeah.
I think it can stay at that point. It's called Seaborn. It's also another library for visualization. I think I forgot to share with you some resources on the same. I'll share that. Yeah, I think we are good now. I think everybody has managed to import that, to even load the data set, and even print out the first 5 rows. Should we continue, or maybe someone is left behind? I'm assuming Mariwa, are you good up to that point?
Mine is giving errors.
How are you getting errors?
I don't know. The first D, the first.
Can
where
you
I'm supposed to
are you in position to share your
import.
screen?
Yes, kindly.
Yeah. Any other person who is getting errors? They are called bugs. Eh?
Are you able to see my screen?
Yes, I think, yeah.
So this is the error I'm getting.
Okay, let's just have a look. Okay. Oops, okay. So pd.read_csv. Okay, where is your data on the file? Okay, let me see
It's
this.
here.
Okay, can you just copy the path? I'm assuming that.
Okay, the part amefanya ambayo ni df is equals, ameweka df minus.
Oh yeah, I see that.
Oh, it's equals.
It's supposed
Okay.
to, yeah, it's supposed to be equal. Yeah. Good. Okay, can you run that?
Okay, so thank you.
Good. Any other person who is left behind? Just want to make sure that we are all moving together. So in case you have a problem, you just raise up your hand. So I said by using the head function, you'll always be like getting the first five rows of data and the headers. These are what we call the headers or the headings of your data set. That is what we are getting in here. And you can see we have a number of companies, we have a number of towns, we have some policies, number of policies that we have in each company. We have the assured amount for each policy, and we have the type of policies. You can see that we can have a motor auto policy, we have domestic, education, agriculture, and others. So I think that is it. And even we have the customer rating. I'm assuming that this one is a data from is a sample data from one of the insurance companies. So the other thing I said it was to check the dimension of your data set. And this one will always be giving us the number of rows that we are dealing with, or the number of entries that we are dealing with, and also the number of columns that we have in our data set. So you just have to print a string here, and then use the df.shape to get the shape of your data set. So the other thing that we are going to do, just to understand this data set of ours.
Excuse me, sir.
Yes.
I'm also getting an error.
On uploading the data set.
Yeah. After printing, like after printing.
Oh, this print, the print shape of the. Do you have everything? Okay, can you share your screen as well if you're in position to? I think by now most of us are able to debug these errors. Amos, are you in position to share your screen very fast?
Yeah.
Yeah, you can share it.
So this is what I've got.
Okay, someone to solve that very fast. We have import pandas, SPD, we have matplotree.
The file not a column is a column is a commas.
Yeah, haja
Quotation
kama
marks.
string.
Yes, it should. Yeah, it should be a string, right? It should be
Yes.
inside. Okay, these this path should be inside some opening and closing marks.
Marks.
That is what we are missing. And even the import. I think you missed something on import matplotlib dot pyplot. It should be dot pyplot splt. You have some typos here.
And then C bonds, ameandika cis bonds.
Yes, I think you can. Amos, I think you can change that very fast. And then if the errors persist, we have Lewis. Lewis, any question?
I have a question. So I remember you were telling us the PDs, PLT, those are just like alias. Like,
Yes. Yeah.
does it really matter how you want to call your alias?
Of course
The
it is.
way, for example, the way Amos was calling his matplotlib as split, does it really affect the general code?
It really affects cause. It doesn't affect it can't affect the output you're going to get, but from the documentation, it's well indicated that you're importing maybe matplotlib.pyplot as PLT, right? So what happens when you go to interviews? They will always ask you, okay, how do you import maybe CBON? If maybe you happen to use a different alias, let's say for CBON, I think um, the impressions that maybe that comes from the guys who is interviewing you, it's maybe you don't understand, or maybe you're not familiar with the with the the allies that is normally used when it comes to importing, or maybe importing pad asset as something else. So it's always good maybe to use these ones that are used in the documentations, so that at least even the interviewer or the person who is maybe want to give you the job can at least it can be easy. Be unajua when maybe you asked how do you import acid board, and then maybe you happen to say something different that is not familiar with the interviewer, he might as well as judge you very fast, right? So it's always good to use their lies that are in documentation, to avoid these judgments from these interviewers. Sawa sawa, Lewis.
Okay. So
Yeah.
we can conclude that we have SIA units for aliases in Python.
No, not really SI units, but we cannot say they are SI
Uh,
units.
I get your point. I get
Yeah,
your
yeah,
point.
yeah. Okay, that is it. I'm assuming Amos, you were able to solve
No,
your issue.
no, still the error is persisting.
Okay, can you share that? I think you're going to solve that for you. Okay, share your screen. Good. Yes, there is this one. You have called it import C bonds. It's supposed to be C bond, not C bonds. Are you able to change that? Change that. Remove that S, and it should be S, not SMS. Good. Uh, Also, you have a problem with the print. You have an indentation between the print should be in line with the DF.
Yeah.
So you should remove that indentation. Again, I think you can just try to run that. No, you have it. Good. Um, so let's move forward to what was I saying? I think you were at the shape. So I think you can as well as check the dimensions. I said that, and we do that by the shape using the df.shape. And you notice this df is the variable name for this variable name. It's holding all your data from this path. So that is what we are using. So it's df.shape or any other name that you use for your dataset. That name dot shape. Yeah, and we are getting 103,6. 6 represents the rows. No, the columns. 103 represents the number of entries that we have. So after that, I think we can just move to the info method. And the info method, I think I already told you what we get after using the info method. So you're just going to get this kind of an output. And this output, how we read it is we have the reg index. I think we're just told that we have 103 entries. That is the number of rows that we have in our dataset. And it ranges from 0 to 102. And yeah, 0 to 102. Then we have the data columns. We have total, which is 6 columns. And then the info method goes ahead and even tell us the names of the columns and the number of entries in each column. So we have the company, we have 102, again town 102, number of policies, assured amount, customer rating. I think customer ratings we have 103. We are going to check that. The data types we have float, int, and object. The memory usage for the data, it has used 5.0 kilobytes. This just to mean is this one is just a small data set. So that is how we read the information we get from the info method, and it will always be similar. It doesn't matter the data set that you're using, it will always give you all this information. I think after that we can just move on to check the summary statistics for the numerical columns in our data set. And you notice in our data set we have like how many numerical columns. I think we have just like they are just like 3: the number of policies, the assured amount, and customer ratings. Those are the columns that have some numerical values. The rest are kind of strings. So let's check what we have in the statistical. How is this? Yeah, summary statistics for numerical columns. And to get that, we use another method that is called describe. So you're just going to use the df.describe. And then in here, you're going to get data such as count, mean. We have the STD, or what we normally call standard deviation. We are going to have the minimum value for each column. We are going to have the quartiles. The lower we have the lower, middle, and the upper quartiles. So I think that is it. And also you're going to get the maximum value in each column for the numerical data. So for the count again, we have the number of policies as 102. assured amount again 102. We have here 102. So the mean again for all those numerical values, we have the mean for the number of policies as 5.05 and 8824, and we have the mean of the assured amount as 61,065.65, other numbers. So the year again you are getting is 2015. Yeah, that is as per 2015. So the standard deviation, again, we have the standard deviation for that column of the number of policies, assured amount, and even the year. The upper, lower, the upper, middle, the lower, middle, and the upper quartiles. We have four for the lower quartile. That is for the number of policies, assured amount, and even the year. We have all this data. The middle, or what you call the mean, this one is the mean. And that is where we have some the mean. That is, I think, we have some values here. That is the middle quartile.
Excuse me, sir.
Yes.
Are we really using the same data?
Yes, we are using the same data.
Oh, okay.
Because what are you getting? Describe that.
I'm just seeing
You're seeing different output. Yes. Do you get different output?
very like I'm not sure if I'm using the same data as yours.
Why? That one must be weird. Okay, can you share what you have so that the rest can? But I'm hoping the rest we are getting the same output, right?
Mwalimu, I think I'm also at that state. I am not seeing myself the years part. I'm only seeing customer rating.
Oops.
The column that is.
That is when you use the describe, the function describe, or the entire data.
Yes.
Okay, Amos, can you share what you have? And also Valentine, was it Valentine? You
Yeah,
can also share what you
that is
have.
what I have.
Yes. Yeah, I think you can just share your screen so that you can confirm. What about the rest?
It's
Levis, do you have the same output?
Yes, I have the same output with Amos.
Okay, let's check that. Let's check that. So this is Amos Sumbi, right? So Amos, I think even from what you have written there, the describe should be a function. So you should include parentheses. It should be no, not the opening and closing. Okay, at the end of describe, you should put some parentheses. That is
Two columns. Two
the brackets, the not the squared ones,
The normal brackets.
the normal brackets. Is that one. Can you try to run that right now?
Yeah.
Yes, you should get that. So who else? Lewis, I think you're also getting the wrong output. You should be keen on what you are writing. Lewis,
Oh, now I thought they were saying something on ears. Also, I don't have the column of ears. I had something like that. But on describe, I had the correct output.
you have it.
Yeah.
Good. I think who else is lagging behind? This one is a very common. In fact, in most cases, when you get to those interviews, these are some of the things that you're going to be asked about the EDA process. That is why I just decided that the entire lecture will be on this. Yeah, you should be getting that. That is from the describe. We have the rating, customer rating. We have the number of policies. Oh, you are talking about the year, the year column, right? But do we really need
Yes.
the year column here? I think that is another question that you should be asking yourself. Do you really need the mean for year?
We have seen your data portraying it, so that's why we have gotten concerned.
Okay, when I ran this, I think that one was maybe from a previous, because even also I don't have that now after running this. But again, when it comes to describe, I don't really think year column here would make any sense because we don't really need the mean for an year for a year. We don't really need standard deviation for a year. The mean year, I don't think. Yeah, I don't think it will make more sense. But what we have here, the three columns here, these statistical data, the statistical summary for these really makes sense to us. That is the number of policies. It's always good to know the mean, the count, the standard deviation, the maximum, the lower, mid, and upper quartiles for such data. That is the number of policies, assured amount, especially the assured amount, and also the customer rating, right? I think these are the main columns that we should be checking. But for the year, I think we saw that for the year somewhere. And I think even I don't have year for. Let me check this data set again. Is in the data set we have here. I think I had dropped that column long ago. Yes, we also don't have that here. I don't know why I dropped that. Maybe I don't know. I can't remember why. It's long ago since I had gone through this data set. But that is it. For this for this lesson, let us just focus on what we have in the data set. In case we need here, we are going to add that. Yeah, I think that is it. So describe will give you that. So the other thing is to check now checking the missing value. In this case, don't think we have. We can just run through this to confirm that we don't have, or maybe we have. Yeah, I think I can see we just have some missing values. When you are doing this analysis, I think I altered this data set. don't know for what reasons I did that, but in this case we have some missing values when you run that, and how we get the sum of missing values in each column is using these using this is null check. And is null check, it will always return a true for maybe for a name for a null a null row, and after that it's going to sum up all those null values. And that is why we are able to see the number of null values for each case or for each column. So we are told that the missing values, say we have the company, we have a row with a missing company. We have also have in the column town we have another missing value, which is 1. In the column of a number of policies, we have another missing value. Assured amount, again we have 1. Even the type of policy. But for the customer rating, we have 0. We have 0 missing values. So the reason we are checking the number of missing values for your data is again to know if you are going like to know if you are going like to fill the null values, because we said that null values in especially if they are many, they will affect the output or the accuracy for your analysis. And that is why it's always important to check the number of the null values that you have in each case. But in this case, we just have like 1 1, and even there is a column that we don't have even a missing value. I think we saw how we deal with null values. You can fill them with mean, random values. You can fill them with mode or even the median for that column. So the other thing that maybe we should check, I think we don't have here. I think we should do away with this cell. I can't remember why I dropped the year column. I think I had another class for why we didn't need that, but anyway, it's okay. So yeah, I think you can just do away with the year column. The other thing is to do some visualization. So after checking all that, and you're not limited to that, you can do some other checks for your data set. You're not limited to checking the null values, checking the statistical summary. You can do as many things as you wish. But in this lecture, I think we can just go through that. So the other thing after doing all those checks, I think now is to do some visualization. Again, visualization, we say that you can always use the visuals that best suit your case. So in this case, I just want us to do a histogram or a density plot for the numerical values. I think you're just going to do away with the year of interest. Yes, I think here we can just use a different. Let's just go to this data set and see what we can use. Have the number of policies, assured amount, policy. Yeah. think in this case we can just try to let me see this. I think you can just use the number of policies. No, the number of policies. Let me just check that again. That's number of policies. So I think you can just do away with these. I think you can just do away with these. We draw something different. And in this case, I just want us to check what that is a distribution of assured amount. Yeah, I think we can change this one to a distribution of assured amount by company. I think this one will make sense. Company. So that in here you are just going to need the data for. Let me see this. We can just have the companies. Is equals to DF, and then we can just use companies, and then what else do we need? That is for and then the companies should be on the x-axis. So I think we should just edit this to companies. I should have companies there, and what else should we have? I think you should have something like count. In this case, count should be on the y-axis, so that you can have distributed of amount by company. So I think you should have the okay. I'm just trying to think distribution of assured amount by company. I think you should just try to check the first 20 columns here. Let's see what we have. Even you can maybe just have the first 40 just to go through these. I'm just trying to check which histogram we can draw from this data. So if you have an idea, you can also as well as share.
How about the company versus the amount assured?
Company versus amount assured.
against the amount assured.
So you should have like
But I
sum,
think it,
the sum for amount. But in this case, we have again, each company has different types of policies.
yeah, it's tricky.
That is why I'm just trying to think of
What if we do one that has the companies and maybe the one of customers in each company?
sorry,
Number of policies.
number of policies, yeah,
Mm,
and the company, right?
yeah.
I think that one makes sense. So that we can have, let's see that we have the companies, and we just need the count for. We need the count of policies. Policies count. Policies underscore count, right? So that you can have df, then we have that is the type of policies, number of policies. Is it not showing me the options that we have? Yeah, number of policies. Dot. I think we have something like value counts. Right, and even before we plot these, let's just make sure that we have the data. So let's just have some print. Just to make sure that we have the right data with us. Various policies.
How have you commented all together the codes you had written?
Sorry? Oh, the shortcut for that. You just have to, you just have like, okay, you just have to highlight all that and just press Control /, Control and then /.
Okay, okay, thank
And
you.
then you're able to comment and uncomment. I just want to make sure that you have all these in order. But is this really the right output that you want? So count. A big deal.
James,
Yes.
should we do the count of policies or the sum of policies?
We want the count. The count for each policy, because we have different policies. We have different policies.
Oh, so
Yeah. So we want the count for
the
each
count of
policy.
type of policies.
Yes.
Oh,
Yeah, that is what
I had understood it wrongly because
yeah,
we have policies as a variable by itself.
yeah, we have policies as a variable by itself. So we need the count for each they count for each policy because we have the number of policies and the type of policies, right? Let me just check that. I'm not excited with this kind of output you're getting here. Policies. Policies. Just a minute. I think just a minute. I confirm something here. Just a minute. Yes, I think we are missing something here. We should be counting the number of policies, the type of policies. Let me type of policy. Policy. And I think this now is making sense because now we have life policies as 11, endowment, motor, motor policies we have. Yes, I think this one now makes sense. This one we can draw a reasonable histogram, so that we can have now company and the type of policies it has. I think that one now will be reasonable. So let us just if we have, okay, let me just confirm that we have the right data with companies. And also as well as for companies, I think we should for companies we have Britam. I think we should choose a specific company. Let's first of all see this. Let us just uncomment these now. And have the figure size is 10 and 15. We have the hist plot as what. Now we're going to pass our data here, which is df, and on our x we are going to have something like company. I'm going to have company, and then on hue I don't think we need a hue. Hue is I think I'll also tell you what is hue and how it is used. I think the rest can just remain the same, and then we just have the title. We have the let's just try to print out these, and I see the kind of data we are getting in here. And we have this kind of a histogram whereby we have, let me see this, Britam, CIC, then Jubilee. Before we print this, let us know how many companies we have here. Let's print out this. I think something there is something missing here. Let me just confirm this history. Now this value is okay. We have the Britam and the CIC having the same value of count. Is that really what we had? Let me just confirm this. Yeah, the count is the same, so we have 9. Yeah, that is. I think something is missing here. I think these should be type of policies. Okay, you are making a mistake here. Yes, this one now makes sense. This one is making sense. Let us just enlarge this diagram now. Yes, I was wondering why I'm not getting the right output. I think we can make it larger. So 25, 25. Good. I think now this one makes sense. This one is making sense to me. Let me do away with the print. And also I can also reduce this one to something like 20. Also this one remain 15. So that at least we have now the policies, the type of policy and the count. I think that one now makes sense to every one of us. So any question, anytime you are drawing a histogram, you must take time to even choose the kind of data you are going to use in the histogram, because you might draw a histogram like the one we had before, but it doesn't make sense when it comes to even to analysis. But with these now, it kind of makes sense now to every one of us. The count, and I think this one now should change to the number of not companies, but the type of policy. Uh, type of policies. The type of policy, and then this one can be count per policy. Count per policy. I think that one now makes sense. So any question? Do we have any question with during that histogram? I think it took us time to
James, I
yes,
have a question,
yes,
but it's
yes,
not related to the visualization.
yes.
Uh, how do you run your course without re-importing the libraries again to your new cells?
Because uh, you notice I didn't import the nini here. So what normally happens, I think I should have explained this. When you run each cell, you see like the import part. Uh, if your imports and loading of your data set is in one cell, and then you just happen to run this cell, it means that these libraries are now like imported all through your file, right? So that is why I'm running each and every file. I'm running each and every file for my case. So meaning that if I just run this file, it means that I'll just use those libraries anywhere within the file. That is why I just chose to have the libraries and loading of the data in one cell, so that I don't have time. I don't keep importing those libraries. Are we good, Lewis?
Yes, yeah, we are good.
Yeah, I think that is it with now the histogram. To you can have as many as histogram as you want, provided you have understood your data, and you have yes, provided you have understood your data. Yeah, I think that is it. You can also move forward
I
to,
have a question, Mwalimu.
yes, ask.
Allow me to share my screen. There is a place in my histogram that is blank.
Okay,
Let me share
let's
my
see
screen.
that.
Yes, it is. There is a part that is blank.
Okay, let's see it. Why is it?
It has a blank. There's a place that does not have the blue bars.
The blue bars.
Yeah.
Okay, type of policy, and I can see your histogram is quite different because you don't have the names of the policies.
Ah, okay.
You're missing the name of the policies. Can you just
Okay.
raise
Let's
it up?
work.
Raise it up so that we can see. You can as well as include the number of the names of the policies, the types of policies.
Okay.
Yeah,
Okay.
just include them.
All right.
Because when you use the type of policies and you're not indicating the type of policies, you might as well as be confused, right?
Yeah.
You can just include the number of the types of the names of the types of policies. Um, what else should we check? I think you can just continue now to the other parts of the EDA process. Um, Also, there is a number of plots that are used to check the outliers in your data set. And in this case, I just want to use uh, we always use box plots, but there is another one that is called violin. And in this case, I think we can just have we can just have a box plot. We are going to see that plot and how it's normally drawn, and even how you interpret that. So the box plot is just quite easy because you just have to specify the size, the figure size. I think I can just use 1010. There is no harm. Or, oops. I can just use maybe 1015 so that it can be large enough. That is 1015. And then you notice that in this case I'm now using the SNS, the Seaborn, to do the box plot. So it's SNS and then dot box plot, and then we just pass in our the values the values that we want on our y-axis and the values that we want on our y-axis, and then we're just going to pass in our data. So the values that we want on the x is the company name. And, you can see that. Then we have the y, the assured amount. That is what will be on our y-axis. Then after that, we just have to pass in our data. So we just want to check the to identify. In this case, now we are trying to identify the outliers and their distribution, right? I think the rest, the title, we have the X label, and the Y label, and then you just have to show that. So I think you can just run through this and see what we have here. Good. Had I mentioned what is an outlier? Who knows what is an outlier?
I
Outliers,
think I
these are extremely large or small numbers that they're not in range of our data.
Yes. An outlier, I think, as Lewis has just mentioned, that outliers, they are just single data points that goes outside far the average value of a group of statistics. So it's these are just data. I think they are um, they just go far outside the average value for the data that maybe you might be having, or the group of statistics. So as a maybe we can have outliers maybe from you can have maybe you had outlier as a result of maybe typos, maybe wrong recording of data, and that is what we normally use. We normally check using the box plot. So I think that is it. And also you can use something else we call the violin. Also it's another plot that is used in to check the outlier as well as the distribution of data. The outliers are these. They are normally whenever you draw a box plot, you'll always notice that the outliers are in these. They are represented by these dots you can see. So these ones just tell us that we have an outlier. In this case, we just have one that goes beyond the normal value of the assured amount. And also we have also one here in the company, that is the CIC. After knowing you have an outlier, you can as well as remove them whenever they are many. I think this one they might not make whenever they are many. Let's say we had some several dots here. That is the only time maybe you can remove them. But like in this case, we just have one. So we just have one. So I don't think it's something to bother us. And this is the reason why I was talking about understanding the data you are dealing with, right? Because let's assume we had so many so many outliers here. That means that it will affect the output of whatever analysis we are going to do. Let's assume we had some values that goes beyond the sum assured. Maybe like this one. I think this one is counting around it's almost maybe 250,000. And maybe let's assume we had several values, or even this one value. This one value can affect the mean for the sum assured, right? And if you were maybe to check from this the sum amount assured, and we check the if you were to check the maximum amount, it is the 241. But what is the mean? The mean is around 61,065. So if you were to check the difference between the mean and the max amount, this is the value that is treated as an outlier here in this case. And I think you can see it's the value that you are getting here, this dot. It's around 241,000. I think that is it. If you were to check the mean, so meaning mean will the mean is just telling us that we have most values concentrated around this point, right? But we have that one value here that goes maybe beyond 240, goes beyond the mean by such this large amount. So that is why it is treated as an outlier. And also you can also check the other one, but this one is just close. So it can't make it doesn't have maybe impact on our data. I think that is it with the box plot. And also this one will help you to know the action that you are going to take. Because like this one, if we had so many outliers here, it means that this one usually it tells us that we have to clean up this data. We have to clean up these outliers so that at least we can be assured of correct results if they were many. But one, I don't think it can affect your output or the analysis that maybe you are going to do. I think that is that with the box plot. You can also check how we use the view line plots. Yeah, I think that one is something that you can do on your own. So the other thing is the scatter plot. Yeah, you can also use you can just do some scatter for both. I think in this case we had here. In this case, I think I had a near column with the data that I was using, but in this case we don't have. So you can also choose to draw some scatter plot. So again, to check the distribution of your data, how your data is distributed based on various factors. Like in this case, we were just checking the how data is distributed based on year. So again, you can use different values. So you can just use maybe the same or the type of policies. I think in here we use the type of policies. Let me see this. Of the company, some assured amount. That is on why. Let me just do away with I think you can just have this one as assured amount, and we have company. Company. It should be company. Well, I just run this and say that you still notice that you are getting a value that is too high. You can see most of the data here, most of the sum assured is below 100,000, right? You can see most of the values are concentrated around this point. So again, we just have that one value that exceeds the normal sum assured amount. Just one value. I think that is it with the scatter plot, and I think we should change this one to maybe something scatter plot of the company and the assured amount. The EDA process is just helping us to understand our data well, right? That is the main purpose of this EDA. What else do we check? I think we should have also changed this one to company. Good. So the other thing I think we should check is the aggregate data by year and calculate mean or sum assured in each year. I think this one would make sense if we had the year, but you can also change this one to company. We want to group this by company. We check the assured amount by company. I think we can check the mean of the amount assured by each company. So that is, we can have this one as the company mean, and that, and we can change this. That is the, these are just some of simple analyses that we are trying to do here. Company, that is company mean. But if we had here, it could make even more sense. So that is average assured amount in each company. I think you can have this one as company also as well. Let's see that. So we have like Jubilee with the highest amount assured. Then we have the CIC, and then we have the Britain. So I think these are just they are just helping you to understand.
James, there's an echo.
Yes, where?
There's an echo in there.
Oh, I thought you said typo. It's echo. Okay.
Yeah.
What about now?
A bit better.
It's better. Okay. I think my device was somewhere close. So I think there is and you notice when you are doing this plot, you can as well as modify. You notice that I've introduced something that is called marker, which I'm just using a 0 here, but you can choose even to omit it. It's only that I wanted to indicate a marker for each company as a dot, but you can as well as use maybe something different, a different marker of your choice. You can go ahead, even put the line style, the color. In this case, I'm using blue, and the line width. I think this one is strong. I can maybe use one, and you notice that the thickness of this line will change. Like this one, you can even maybe use a 0.5. Let's see what we have is 0.5. Now you notice the line even it's thinner, right? It's a matter of learning and practice that you're going to get all these. Um, any question? I think that was the EDA process. And you notice here I'm also using the grid. I'm setting it to true. That is why I'm having some grid here. But you can as well as set it to pause or even omit it if you don't really want it. I think I said that yesterday. It doesn't mean much, it's just for aesthetics. So true, you can just set it true, return it to true. Yeah, that's all about the EDA process. And we are going to see some, when you come to machine learning, you are going to see how we can use this process before we make any, before you even determine what model to use. Right? Any question? I think that's all
Wait, Dogu.
for today. Yes.
Excuse, I think
Yes.
I have some questions.
Yes, ask.
Boo, just go to the last visual kumetengeneza.
The last part.
The last visual. So
this one, right?
no, and for the code, the syntax.
Oh, here.
Okay. So you note,
Yes.
kitu nimeona hapa ni plt.plot company index.
Yes.
Company underscore mean.index. But ukikuja hapa kwa the previous plot, go to the previous plot.
Where is it?
Okay, unakuja SNS x equals to company. Nimenote why are we now putting this one in quotes hapo kwa company, but now ile ingine ya chini tujeka in quotations.
Let me see this one.
Yes, unaona hii tujeka in quotations, so inakuwa plt.plot company underscore index dot.
Okay, these are two different. These are two different plots, and for each plot, you notice that each plot has its function, right? And its function, it means that for that function, it will just take some arguments, a number of arguments, right? So for scatter, we just take the x and the y, and we just pass in the data, and maybe you can put some aesthetics, right? And that is why you have just passed the company.
Okay, my question is,
yes,
you see, hapa to make a company, the column tunataka kuweka as our x-axis to make in quotations.
Yes.
But now when it comes to this other one, we have not put anything in quotations.
This one.
Yes, hapo kwa plot. So you see what you've done. Me I've done nimefanya ya bar plot. Na bar plot pia naona pia siweka quotations na imerun. Lakini nimeweka x equals to company underscore index dot underscore mean dot index. So my question is, as there conditions whereby we are supposed to like put the quotation marks, are there conditions where we're not supposed to put depending on the graph that we are
depending on the graph that you are drawing? You notice, maybe I can answer that by maybe telling you that you notice that whenever you are using whenever you are doing the plots, right? So like in this case, you notice that for x, we are just passing the number, the type of the column, the name of the column, right? And this name of the column, you just have to put it in quote, and you just have to put it in quote so that it can like this is the syntax for picking a particular column, right? But you notice in here, like this one, right? The company mean dot index. This one is a different thing because I'm just taking the company mean, which is the value that I'm provided with by this by this line of code here. This is a value, right? This is just a value. And at this value, if you are to go again through this, if you are to go through this code, you notice that I'm also passing the company name, right? And this company, the company column will pick all the data in that column. I go ahead and even pick another column, but in this case I just want the mean. So you must, if you want to pick the data for, if you're interested in picking the data for a certain column, then it must be in these quotes, right? Depending on the kind of graph or maybe plot that you want to do. Are we in agreement? That is the case. In this case, I'm just passing passing a data directory, that is company mean. But you can as well as bring this code here, all this code, because this company mean it just represent data. The company mean, it just represent the data, the mean for that matter, mean for this the shared amount by, and we are grouping that by company. I think even you can just try to do a print here, and you are going to see what we are talking about. It all depends with what you want to do. Let's see that. You notice that grouping by, I'm getting company, that is Britam, and the year mean, right? So it's kind of, I'm just passing the data directory instead of having like writing all that code here. Sawa.
Okay, so
yeah. Should be that. You said you had questions. That is the first one. The second one and the third one.
nilikuwa nataka tu, I just wanted a clarification.
Just a clarification, okay.
Yeah, because for the previous ones naona
Hatujaweka
in quotations, but maybe this is because hatukuwa tumeaggregate.
Yeah.
We are speaking, yeah.
That should be the thing. But take time and go through the EDA process. I'll share with you these notes. Take time, go through it, so that tomorrow now we can get into machine learning. So, any question?
Maybe just my last question. Yes. I saw somewhere kwa cargo, they were doing a heat map. Could you also do a heat map hapa tuonione vitaka? I'm sorry, but just a heat map.
You just want a heat map. Which is the best case to use a heat map? Yeah, we can do it. We can do one. just in fact, heat map. See that? I think I can just have it here down. But the heat map we are going to use it most in machine learning. I think that is why we are going to use a lot of heat maps. What do you want to include in the heat map? Yes. What data do you want to use in the heat map?
For the heat map, I think ilikuwa because heat map normally checks the correlation if ama niko wrong.
Check the
correlation.
Yes, check the correlation. For which variables now do you want to get the correlation for?
We can check for the assured amount and the customer rating. Right? Yeah,
Sorry?
assured.
Isn't there the correlation of
assured amount and customer rating.
And the customer ratings. Okay, you can have that very fast so that you can drop off. So again, it's just quite easy because again, it's just going to specify the figure size. We can have a PLT dot the figure. We normally do it figure. Then the fig size should be the fig size. Then you can just pass in some. You can have 10,8. But this one now bring us to a different thing because we didn't learn the correlation matrix, right? This one is bringing us to a different thing because
correlation.
I think most of us will be left behind here. Let us just check the correlation matrix for the for the values that you have just said. We can just have the call. Or let us just do the correlation for the whole thing so that we cannot take much time. So let us just have the div dot the call. This is how we check we just have the correlation. I think you can even just check we have the correlation matrix here for our DF. Oops, let me see what it said. For the Britain. Let us just do something here. So let us have a new DF. And in this new DF, we just want to use a number of columns. Like in this case, you can just use, let's check. Show this one, okay. Let us just use the no, not town, but you can just use the number of policies, assured amount, right? I think you can just use 2. Number of policies and assured amount. So let's just check that. So you have DF, and you just want to use the number of policies, comma something like assured amount. Just want to make sure that we use the right. Should be the assured amount. No, this one. I should be assured amount. Let me just use that. And now here we are going to use the new DF. New underscore DF. Let us just see that. Oops, sorry, getting this. Let's check this. You can just check this. Let's just check this error. I think you should now make Google your friend, right?